So for our next example, we have a 20 centimeter long wrench. I'm going to follow the steps again and draw my picture first. In this case, I've actually printed off a picture of a wrench to give us a better idea. Now, we're going to hold the wrench at a 30-degree angle, as stated in the problem. And we're going to apply a force straight down. So if I were wanting to get the most torque or the most rotation, I know that I'm going to need to apply a force here at the end of my wrench. And I'm going to apply that straight down. And that force is equal to 100 newtons. All right, we need to find the torque. That's what the problem is asking for. So first of all, I know that torque equals my perpendicular force times my radius. So I need to find this perpendicular component. I'm going to go ahead and draw it. Here's my perpendicular component, and here is a parallel component. Now the parallel component is not really important to me, but I'm going to draw it so that I can see my right triangle, because we're going to have to use trig, of course, to find our perpendicular component. Now, here's where geometry comes in for us to find our angle. If this is 30 degrees, here's one triangle. Let me just highlight my other triangle here. Here's one triangle, and here's another right triangle. If this is 30 degrees, and this is 90 degrees, that means this angle up here should be 60 degrees. Now, right here at this corner, we have a 90-degree angle, so if that's 60 degrees, that makes this angle right here 30 degrees. Or congruent to that angle. So that's going to help us find our perpendicular component. Our perpendicular component here is adjacent to 30 degrees, so I'm going to use cosine to find it. F perpendicular equals my hypotenuse, which is 100 newtons, times the cosine of 30 degrees. And my radius is equal to 20 centimeters. So remember, if I want to find my torque, I'm going to take my perpendicular component and multiply it by the radius. So, torque equals 100 times the cosine of 30 degrees times 20 centimeters. I do need to turn that to meters, so that's 0.2 meters. So that gives me a torque of 17 Newton meters. Now I need to determine, should that 17 be positive or negative? Well, this perpendicular component is going to cause the wrench to rotate in that direction. Anytime you have this that is clockwise, that's the direction a clock would go. So that means that we have a negative torque. So I'm going to go ahead and just make this negative here. So my total torque is negative 17 Newton meters.